Hey guys, today we're going to be going over color sensor calibration and a basic line following program in the EV3 Mindstorm software. So first things first, just make sure you have your EV3 brick with you. And yeah, without further ado, let's get started. So the first thing that we're going to be doing is calibrating our color sensor. I'm sure the majority of you know what port view is and how to use port view on the EV3 brick. But if you don't know how to use it, I'll take you through it really fast. So when you boot up your EV3 brick, you'll be on the start page initially, which is the one with a little play icon. If you press the right button 2 times, you'll eventually end up on a screen that has port view, motor control, IR control, and brick program. Go ahead and click on port view really quick. So port view is really helpful in that it allows you to kind of track all of the motors and sensors on your robot. So on my robot, I have a touch sensor and a color sensor. My touch sensor is connected by a wire to my 1 port on my EV3 brick. My color sensor is connected to the 2 port. So basically, if I go into port view, I can actually see what my touch sensor in this case is reading. So since my touch sensor is not currently being pressed, it'll show a 0. Also, if you want to look at port view through the EV3 Mindstorm software, if you take a look at the bottom right of my screen, I can head over to port view, click on that, and as you can see, I have all my sensor values right here, including motor, all my motors and everything. So currently, since I'm not touching my touch sensor, or I'm not pressing it, it displays a 0. And if we go over and look at the touch sensor block right over here, let's see, touch sensor, compare states. 1 is actually mapped to pressed and 0 is mapped to released. So in its current state, my touch sensor is in 0. It's not being pressed. However, once I press it, it'll change to 1. And you can see that in the bottom right-hand corner of my screen, it immediately changed to 1. So similar to how you can do this with the touch sensor, you can also do it with the color sensor. So if you move over to whichever port your color sensor is connected to, mine is connected to the 2 port, you can actually look at the reflected light intensity of your color sensor. If you want to, you can also change this to ambient light intensity or color. For now, I'm just going to keep it on reflected light intensity because that's probably what you're going to be using the most. All right. So currently I have a black line and I'm driving my robot on a white surface. So as you guys probably know, white surfaces, or light colors in general, reflect a large amount of light, whereas darker colors reflect a really small amount of light. So currently I have my robot on my white table, and as you can see, it's reflecting a really, really high percentage of light. Actually, it's over 100, which shouldn't be happening, but it should be relatively high. And if I move my robot over to the black part, or the darker color, which is my line, it goes all the way down to 0. So ideally, this is what you want. When your robot is on a really light color, it should be around 100, or it should be a high value. When it's on a dark color, it should be 0, ideally. But that's not always going to happen, and this can happen for several reasons. So prior to me actually calibrating my color sensor, I had a value of around like 28 for me being on my white surface, and it was around like 4 for me being on the darker surface. So something was clearly off, and this is the way that you can calibrate it in the EV3 Mindstorm software. So the first thing that you have to do is go over to the yellow sensor department of your EV3 Mindstorm software, and go ahead and drag on out the color sensor block. So this is literally just the block for the color sensor, and make sure it's connected to the right port. In my case, it's port 2. If you go ahead and click on Measure Color, you can change this. There are 3 separate options. You have Measure, Compare, and Calibrate. Go over to Calibrate, Reflected Light Intensity, and at the beginning, I'm just going to reset all of the values, so everything will be reset to what it was initially. So we want to find a way to say, if we wait for one of our brick buttons to be pressed, once that brick button is pressed, our robot or our color sensor will be looking at a certain surface, say a very light surface, and when that brick button is pressed, the color sensor will automatically set that value to 100, or to a very high number. All right, so here's how you do that. So first things first, we're going to want to go into our weight block and change it from time to brick buttons, compare, and then brick buttons. You can keep it as the default brick button, which is the center brick button, but the big thing is we're going to want to change this to bumped. So basically what the bumped option does, or at least on the brick button, is it waits until the brick button is pressed and then released again. In other words, if we were to have two of these weight blocks, which we will end up having in the future, and if we were to keep it on pressed, then it would just do the two things pretty much instantaneously, because there's no gap separating them. It's not waiting until it's released. So for this purpose, we should be using the bump setting. So make sure you have that. All right, now we're going to go over to the sensor tab once again, and we'll drag out the color sensor block. And we're going to say color sensor measure the reflected light intensity. So as of now, we're basically saying reset the color sensor, just recalibrate all the values, wait until the center brick button is bumped, and then once the center brick button is bumped, measure the reflected light intensity of the surface that the color sensor is currently looking at. Okay, so far so good. Now we have to take another color sensor block, and we have to go over to Calibrate, reflected light intensity, and maximum. And now we have to drag this data wire over to here, connecting this one to this one. Okay, so basically what this is saying is that once this center brick button is pressed, measure the color sensor, measure the reflected light intensity of whatever surface the color sensor is on. In this case, it should be a light surface, like a white table, and then set that to the maximum value, which in this case is 100. Hopefully that makes sense. Okay, so now that we have that for our light surface, or a white table, now we have to do it for our dark surface, which in this case will be the line for the line following program. So we'll essentially just have to do the same thing, but instead of doing maximum, we'll do it for the minimum. So you can just copy and paste all of this by doing Control-C and then Control-V, and then simply drag it here. But this time, instead of saying maximum, we'll say reflected light intensity minimum. And once again, we have to drag this data wire over, and that's pretty much our program. So in general, we're saying recalibrate or reset all of the values of the color sensor, wait until the center brick button is pressed. By this time, you should already have your robot on a light surface before this is pressed. Actually, let me just add a comment here saying place robot on light surface. And then right before this weight block, I'll say place robot on dark surface. Right. So you place the robot on a light surface, and then once you're ready, click the center brick button. It'll set whatever it's currently looking at, or it'll set whatever the current reflected light intensity is to the maximum. Place it on a dark surface, it'll set this to the minimum. All right, let's try it out. Okay, I've finished my program, and if you take a look at my port view in the bottom right corner, you can actually see that since I'm currently on a white surface, or a light surface, my reflected light intensity is at 100. If I were to change this to color, it would show up as 6, which, if I take a look at the color sensor block, give me 1 second. 6 is indeed the code for the white color, so that's good. And if I were to move it to a dark surface, change this back to reflected light intensity, I get something around 0.61, which is really good. So this is how to calibrate your color sensor in the EV3 Monstrum software. All right, so now we can kind of put this to work. So let's go ahead and make a new program. And we're essentially going to be doing a line following program. So before anything, make sure that you have some sort of line. For me, I just have kind of like a large strip of black paper set up on my table. And as I mentioned to you before, my table is white, so it presents a nice contrast between the reflected light intensities. Okay. So as I mentioned before, this is a relatively simple line following program, so it should work for most purposes, but for something like First LEGO League, we may need to dive into a little bit more complex of an algorithm. But for now, let's go with this. All right, so the first thing that we're going to need for this algorithm is a loop, and we have to put a switch inside the loop. So keep in mind that whenever you have a switch block in LEGO EP3 Mindstorms, it pretty much always has to be within a loop, because if you only have a switch by itself, it'll only repeat the action once. So if you want it to happen multiple times, which is what we're going to be doing in this case, you should always keep it within a loop. All right. So now we're going to set the parameter within the switch, not the loop, but within the switch, to color sensor compare reflected light intensity. All right. So one of the best things about this calibration in the color sensor is that it can actually, or you don't have to necessarily kind of calculate what this threshold value is going to be. As a matter of fact, it's kind of set up perfectly right now. It's basically saying if the reflected light intensity is less than 50, then do this. If it's greater than 50, then do this. And that's perfectly fine right now because, once again, if you take a look at port view, on my white table, it's 100, and on my black surface, it's around 0. So 50 is the perfect value because you want to find something in between for this specific program. All right. So there are kind of two ways of doing this. One way is by starting your robot on the right side of the line, and another way is by starting your robot on the left side of the line. For the purposes of this program, I'm going to start my robot on the right side of the line. So if you were to have just a line of tape or something, then start it kind of in between the right edge of the tape and your table, and that's where I would probably start it, or at least that's where I have it. And if you actually take a look at my port view, it shows it around 39.5, which is kind of what you want. It's not too bright, it's also not too dark, because it's kind of combining the two values. Okay. So now what we're going to say is, basically, if the robot sees a dark value, in other words, if it sees the line, the black line, it's going to want to turn right. Whereas if it sees the white table, it's going to want to turn left. And keep in mind that this is a line following program for the right side of the line. So in a way, it'll kind of be zigzagging along the right side of the line as the program goes on. Hopefully you understand that. So how do we kind of put this into code? So the first thing that we're going to need is a move steering block. If this makes it any easier for you, I can change this to compare and then color, and all I have to do is set this to black. So in other words, if the color sensor is on a is on a black line, then do whatever's here. And as I mentioned before, if it's on the black line, we're going to want to turn right while starting on the right side of the line. You can think about it this way. If you were to turn left while you were already on the black part of the line, then it would essentially just veer off the entire track. You basically want it to kind of zigzag in between, or zigzag on the right edge of the line is what you want to do. So we'll change this move steering value to around 15 for the steering input, and we can keep this the same and turn it to on so that it repeats not just for one rotation, but it just stays on. And so that's kind of if the robot, or if the color sensor is on the black line. But if it's not on the black line, then we need another move steering block. Set this to on, and we'll say -15. Okay. So essentially what we're saying here is that if the color sensor is on the black line, then it turns right to avoid veering off, whereas if it's on the white part, or if it's on the white table, then it turns left, so it gets back on the line. And as I mentioned before, this makes it so that it kind of zigzags on the right edge of the line. It's pretty cool. Okay, let me go ahead and make a comment, and I'll say this is for the right side of the line. So what if you want to do it for the left side? Well, it's pretty easy. You would essentially just have to reverse the code. So if I want to, I can copy and paste this. Or not necessarily reverse the code, but reverse the move steering values. So think about it. If you were to be on the left side of the line, which I'll edit this here, left side of the line, kind of to prevent veering off, if the robot sees the black line, then it'll want to turn left. But if it sees the white table, then it'll want to turn right. So let's put this in the code. If it sees black, it'll turn left. And if it sees white, it will turn right. And the reason I'm choosing -15 out of all values instead of something like -50 is because it's a relatively small turning increment. So if it were something like -50, it would be kind of zigzagging a lot, and it would be turning a lot, and as a result, it wouldn't be that accurate. But if you make it something small, or relatively small, like -15 or +15, it won't zigzag around as much. But yeah, this is what the code is. Alright, so now that we're done with this, I want you to try out 2 challenges. So the first challenge is, what if you wanted this code to execute, but you wanted it so that the program would stop once the touch sensor is pressed? How would you do that? Alright, so the solution for this is you would have to change the loop value, not the switch value, but the entire loop value from unlimited to touch sensor state. I'm going to do that for this one as well. So in other words, it's saying that the loop's exit condition is when the touch sensor is pressed, and that's all you would have to do. Alright, now one more challenge. What if you wanted this program to stop following the line after a certain distance or a certain period of time? So one way of doing this is by something called motor rotations. And the way motor rotations work is if you go to the loop's exit condition, and you can scroll over to motor rotations, and we'll say rotations. So basically, the way motor rotations works is that whenever your robot, or whenever the wheels on your robot complete one full rotation, or one complete 360-degree turn, it counts as one rotation within the robot. So actually, if you go over to port view once again, as I mentioned, port view is really helpful. You can set this to rotations. This is, I believe, the right motor. And if I move my robot forward for, I'll try to approximate it, but for one rotation, you can see it moving, and just around there. So 0.9, 330 degrees, pretty much the same. So you can kind of use motor rotations as a way to track the distance that your robot is moving. Or you can do some sort of conversion factor between centimeters and motor rotations. Alright, so here in this program, we have to say that the loop should end when the amount of motor rotations is greater than, we'll say greater than or equal to, greater than, and then we'll have a certain threshold value. So let's say 10. So in other words, the robot has to complete at least 10 rotations for it to finish. Okay, and then we can do the same thing for this here. But yeah. Alright, in the next video, we're going to be doing a slightly more complex line following algorithm. But as I mentioned before, this works for most purposes. But if you're looking for an additional challenge, I highly advise you to check out the next video. Alright, thanks for watching. See you next time.